We'll proceed in vector, summation, and integral calculus. Vector, summation, and integral calculus. We have showed that there are two ways to bring a summation into integral calculus. Means the discussion that we have pursued. Okay, the discussion what we have pursued till now, that there is a something called multiplication. There is something called multiplication, and multiplication can be achieved through many ways. Two ways at least I know. Multiplication. A multiplication can be achieved through two ways. One is called repeated addition, and one is drawing the graph. Drawing the graph. If I say I want to multiply 2 into 3, then I can draw a graph where x-axis is 3 and y-axis is 2. It makes a rectangle. If I'm able to calculate the area of this rectangle, probably not by the multiplication, by any other mean, there can be many means through which we can calculate the area. One mean can be that I have a small square, 1 meter by 1 meter, or 1 unit by 1 unit, one small square. Okay, that I can fit in the area. If I want to measure the area of a shape, okay, okay, I want to measure the area of this rectangle. What is area of this rectangle? Then I'll take a small square. Okay, this is a very big square, very big rectangle. Take a small rectangle, very small rectangle, 1 unit by 1 unit, and then place it inside the rectangle. Okay, small square, and place like this, and count how many square have been placed. Take a small square and place like this, so many squares like this, and then count it. That is the area of this. So area can be computed in that fashion. And whatever area comes, that is the 2 into 3. That is the repeated by drawing the graph of two operand of a multiplication. A multiplication has two operand and one operator. Two operand, one is width of the rectangle, one is height of the rectangle. If I am able to calculate this area by any other mean than the multiplication, then multiplication is that. Or 2, or if I say 3 into 2, then 3 2 times, 3 plus 3, 3 into 10, 3 plus 3 plus 3 10 times. This is also a way to calculate the multiplication. There are other ways also. One way I have seen, but I don't remember it. There is also a mathematical way where you do some computations, write some expression as per the multiplication, and at the end you add it. That is, there are many ways. People, as per their need, geography, and other things, related things, they bring many other fundamentals of calculating the multiplication. The way to calculate multiplication through the graphical way is called integral calculus. Integral calculus is nothing more than this. Multiplication through graphical way is integral calculus. That's it. That branch, Mr. Newton or Sir Isaac Newton, he took that branch of the multiplication, that is calculating the area through graphical way, as calculus. Okay, and then he proceeded. So the basic shape of the calculating the multiplication is multiplication of two items where height is fixed and width is fixed. Now I can go more, I move toward algebra, then more we will move toward abstraction. So height is 3 and width is 2. Height is 3 and width is x. Now one I introduced as algebraic. Then height is y and width is x. Both are algebra now. Okay, where height is y and width is x. Y is constant. Height is y and width is x. Height is y everywhere. Then people started, if I draw graphically, then this is x-axis and this is y-axis. This is x-axis, this is y-axis. This is origin. This is origin. This is x-axis. This is y-axis. In that fashion, this area is y into x. This area is y into x. X, this is x axis, this is origin, this is x. This is origin, this is y. Area is y into x. What about y? Okay, now the people they started investigating it into more. Okay, in that fashion, people said that okay, when x is growing, y is not growing, y is constant. Okay, people can take in this fashion also. When y is growing, see the y is growing in this direction, x is constant. Okay, means y is not dependent upon x, x is not dependent upon. This is now the fundamental of dependency started coming. This is dependency. Now then people saw, consider this is x-axis and this is x-axis. Consider this is x-axis and this is the graph. This is y-axis. This is x-axis and this is the graph. Then people started watching when x is growing, then y, that is the height, is changing. Okay, sometime y is growing also with the x. After that, sometime y is decreasing with the x. Now tell me the area. Tell me area, it is still y into x. Now this y into x is the area. It becomes an abstract area. This is not the real area, but still people write height into x is the area. Y into x, width into height is the area. Where y is variable with the x, y is changing as I move in x. Still I write y into x as area. Now people would say that matter is going serious now. We started with 3 into 2, remember? Where 3 is height and 2 is width. Then we said 3 into x, that was also alright. Then we said y into x, that was also alright, when y and x are two different things. Now y is varying with the x. Then I cannot say y into x is the area. In abstract manner, I can write y into x is area. But y is changing with the height is changing with the x. Now the notation is different. Now it is y into small d in front of x is dx. Now saying that the left hand side of the multiplication, that is y is a dependent component and is depending upon x, where x is changing, then if x is independent and the way x is changing, y is also changing through some function, that is called function over x. So y, which was a height, now it is renamed as function and in bracket over x, because y is changing with the x, fx into dx. This is the exact representation of multiplication when we are trying to achieve through graphical way, and one is dependent and one is dependent. See, simple multiplication, it came to what stage now? Where one is dependent and one is independent. Function over x, that is y, is dependent and x is independent. And their multiplication no more can be written as fx into x, fx dx. This is the typical, this branch of calculating multiplication through area, through the area in a graphical way is called integral calculus. That's it. From here only calculus starts. From here only. This is the first point in calculus. First point. Okay, then people start seeing that if the height is constant, consider k, and width height, means this is the height. If this is a rectangle, then height is always, if this is a rectangle, then height is always constant. This is x-axis, then height is always constant, same everywhere. Okay, this is same everywhere. So what is height? Height is 2. I can write as 2 into x to the power 0 into dx. That is the area. Okay, what will be the area now? It will be 2 into x. Okay, means 2 into x. 2 into x to the power 0 integration. Now dx, actually that is the one of the multiplier here. People, they just keep it aside. Dx, keep it aside. Dx is as if it is some key into a lock. Actually dx is the multiplier. So if I have a height of 3 and I have a width of x, it is 3 into x. 3 dx. 3 into x to the power 0 dx. Dx people forget it completely. Now everyone focus on integrand only. What is their integrand? 3 into x to the power 0. Then its integration will be 3 into x. But actually the right hand side is the main thing. It is half of it. Half of it is 3 into x to the power 0. Another half is x. Since it is always x, dx, people they discard it. This part, what is integrand part? Integrand part of a calculus is only height. Width is that side. That side. Anyway, if height is 3, then it is 3 into x to the power 0. Then its multiplication with x is 3 into x. Now people say, remember it was 3 into x to the power 0. It becomes 3 into x to the power 1. What about if height is x? This is height is x. If this is x-axis, then height x is varying like this. This is the height. When x-axis is 0, height is 0. When x-axis is x, height is x. Height is going varying like this. What is the area? That is x into dx. Height is x, function over x is x into d of x. Okay, what is the integration of? Generally people say, what is integration of x? These are the vague things people talk. What is integration of x? This is the wrong thing. If I draw a graph of fx equal to x on the x-axis, what is the area underneath it? Or what is fx into x? This is fx. Then fx that is the height. Fx into x, what is that? Or what is the area? What is integration of fx? Doesn't make any sense. What is multiplication of fx? I'm asking this question. What is multiplication of x? Anyone would laugh. What do you mean? Yet I'm asking, what is multiplication of x? People will say he is gonna mad now. What is the question are you asking? What is multiplication of x? Multiplication with what? No, multiplication. It is same thing as what is integration of x? Integration means multiplication only. I have showed it very well. Consider this is multiplication. Then multiplication can be achieved through many algorithms. One algorithm is repeated addition. Through this also multiplication can be done. And one way is through graphical way. This way also multiplication can be done. There can be other way through which multiplication can be done. If I say I have a repeated addition, then it can be brought into multiplication. Other way, if I have a multiplication, multiplication can be achieved through repeated addition. If I have a repeated addition, it can be brought into multiplication. And then multiplication can be achieved through graphical area. If I have a graphical area, it can be brought into multiplication. And multiplication can be achieved through repeated addition. Whatever. Multiplication is the mediator. That is the main thing. Anyway, if I say, can you integrate fx equal to x? Someone would ask, what is integration? Integrate means multiplication, yeah. Then what? Integrating fx with what? Dx. Or okay, understood. You're trying to multiply fx with x. Yeah, I'm trying to multiply integrating fx over x. That is also loosely okay. Integrating fx with x, multiplying fx with x, multiplying fx over x. No one talk like that. Multiplying fx with x, integrating fx with x. Okay, if this is fx, that is the height any moment, integrating fx with x can be written as fx dx. If fx is x, then it will be area of this. That is, this is x, then it will be x square by 2. Then it will be x square by 2. Means integrating fx, that is x, with x is x square by 2. Loosely I can write now, if integrand is x, then integration is x square by 2. Integrand is x0, then integration is x. Means if integrand is x to the power n, then integration is x to the power n plus 1 by n plus 1. This is the beginning. This is the beginning of calculating the area. If I have a graph, if I have a graph, if I have a graph, if I have a graph where this is x-axis and this height at any x is x square, then the area underneath it is x to the power 3 by 3. Okay. If it is x to the power 4, then area underneath is x to the power x to the if it is x to the power 4, then area underneath is x to the power 5 by 5, like that, x to the power n plus 1 by n plus 1. What is integration of e to the power x? That we will talk in, in post session, in future session. What is integration of e to the power x? Okay, how to calculate integration of e to the power x? E to the power x plus 1 by x plus 1? Okay, no. Integration of x to the power x, what we know. Okay, what is integration of a to the power x? That also we don't know. What is integration of a to the power x? Okay, what is integration of log x? What is integration of log x? That also we don't know. Okay, what is NT of integration? Differentiation. What is differentiation? If I have a function f, if I have a function fx, and if I integrate with x-axis, multiply with the axis or compute the area, fx dx equal to gx. Okay, now I have a gx, that is integration of fx with x. I have gx. I want fx back from gx, then I will rewrite dgx by dx, or fx into dx equal to gx, then fx equal to gx by dx only. Anyway, that is called differentiation. Differentiation means how to get back a function for which integration is gx. Makes sense? This is the exact definition of differentiation. If I have a function called sin x, what is differentiation of sin x? Differentiation of sin x will be another function called fx. Okay, I mean, if fx is a function for which integration with x-axis is sin x, then what is fx? That is differentiation of sin x. Makes sense? If I have a gx and I want to calculate differentiation of gx, then I have to find a fx for which integration is gx. That is the differentiation of gx. dgx by dx equal to fx means fx integration with dx is gx. If I find out any function fx whose integration is gx, then dgx by dx is fx. But it makes big sense to have differentiation. Why? Because calculating differentiation is very easy. Anyway, if integration of x to the power n is x to the power n plus 1 by n plus 1, this proves that differentiation of x to the power n plus 1 by n plus 1 is x to the power n. This proves that differentiation of x to the power n is x to the power n is n into x to the power n minus 1, the way it is. Okay, okay. What is the differentiation of tan x? What is differentiation of log x? Okay, people would ask this kind of thing. What is differentiation of log? Everything starts from rectangle one, basic shape. Okay, base integration of the most basic shape rectangle. From there, we found that integration of x to the power n with x is x to the power n plus 1 by n plus 1. Then differentiation of x to the power n is n x to the power n minus 1. Slowly, people started moving from here only, slowly. Okay, if someone is trying complex equation, they will try to break into the polynomial, and they will get the kind of solution through the antiderivative. Antiderivative is integration, and anti-integration is derivative. Okay, so people proceed in that person. Anyway, now the concept arriving. Taylor series. Taylor series is a very big thing. What do you mean very big thing? Taylor series is a very big thing. Taylor series is a very big thing. Taylor series gives a polynomial representation of any wave. Polynomial representation of any wave. What do you mean by polynomial representation of any wave? Okay. What do you mean by polynomial representation of any wave or any equation? If I say I have a function called sin x, if I have a function called sin x is typically like this. This is sin x. Okay, where in between x-axis is passing. Half of the lobe is above and half of the lobe is down. This is called sin x. This is sinusoidal in bracket x-axis, sin x. This is called sin x. Okay, can sin x be written as a polynomial equation? Some constant plus some constant into x plus some constant into x square plus some constant into x to the power 3 plus constant into x to the power 4 plus some constant x to the power n. What is benefit of this? Benefit of this is if I have a sinusoidal wave, if I have a sinusoidal wave, if I have a sinusoidal wave, then sinusoidal wave can be generated, electronic wave, if I have electromagnetic wave as a sinusoidal wave, then sinusoidal wave can be generated by adding so many waves. One wave has a, one wave, one wave is rectangular wave, makes sense? Sin x equal to a constant. Constant means it is a, if this is x-axis, if this is a x-axis, then this is a constant. A wave that is proceeding, a wave that is proceeding without any acceleration. Makes sense? It has a velocity, constant velocity. Okay, it has a wave. Hope. I don't know. Okay, if sin x, if sin x is the distance, if I say sin x is the distance, then I have a first is the distance. Distance means it has some power and it is constant. Plus a constant multiplied by x. X means something is has a constant velocity. Means distance he person is traveling. A person is running at a constant velocity. That is x. If this is x-axis, then this is x. I'm trying to model sin x. Sin x equal to a0, that is a constant, plus a1 into x plus a2 into x square plus a3 into x to the power 3. A0 is constant. Means if sin x is a if sin x is a wave, electromagnetic wave, and x is a time. X is time, and sine is the power of wave at any moment. Like I'm an antenna. I am an antenna, and I am kind of interfacing. I'm interfacing electromagnetic wave. It is coming from somewhere, and sometime I see there is no electromagnetic wave at all. Then suddenly I start seeing that electromagnetic wave is growing. At one time, I am seeing maximum electromagnetic wave has power has reached. Then I start seeing electromagnetic wave. The intensity of the wave is decreasing, and again it is coming back to zero. Then I start seeing electromagnetic wave power is increasing again, but in opposite direction. Opposite direction means wave was coming like this towards me, and it started growing, reached maximum strength, and then it started decreasing in strength, but still wave is coming in this direction only. After some time, I am seeing when it reaches zero, wave is going in opposite direction. Up. Okay, wave has reversed its direction, and then it is again increasing and decreasing. When it comes to zero, then wave is coming from this direction. If I talk in polarity of the antenna, if this is the antenna, consider this is the antenna. And when I talk about the polarity of the antenna when it is receiving the wave, antenna will say plus and minus. Which side is plus and which side is minus, like a battery. So this is plus and this is minus. If I add a voltmeter across it, then voltmeter will start showing the potential difference that will start growing from the zero. It will reach maximum and it will come down. And then voltmeter will start showing the potential difference in negative. Means it has switched its polarity. This was positive and negative for the first cycle. Then now this is negative and this is positive because the wave is coming from this direction and going in this direction. Looking at that, wave has reversed its direction. Positive is this side. Okay, if wave is coming like this, then this is positive. If wave is going like this, then this is positive. But in my voltmeter, it has switched its polarity. First this was positive, this was negative, and now this is positive, this is negative. Okay, this is the scenario. If wave is coming like a sinusoidal wave, can I regenerate this sinusoidal wave with a mixture of many waves? This is what I'm saying. With a mixture of many waves. One wave has a potential that is fixed, that is A0. Makes sense? This kind of explanation may not be available in the book. Sin x equal to a0. What it tells us is, first we understand it. Sin x equal to a0 means if I put across antenna a voltmeter, always it is showing one voltage, fixed voltage, always, not changing at all. That is a0 plus a1 into x plus a1 into x. a1 into x means I have some magnitude, and that magnitude is growing. It started with a1 and then a1 into x. X means at the time of t, x comes, consider a1 into x. Sin x is the power at any x. X is the time, equal to a0. That is the power that is fixed at any time. Independent of the time, I have this much power. Sin x is a voltage across the antenna at any time x, equal to a0. That is the voltage across antenna, always there. Leave the sin x. Sin x now. If I keep the voltage across antenna anytime, what do you mean? Let's consider this antenna with so many wires. This is wire number one. I have a red wire and green wire, red wire and black wire. And that wire is connected to the antenna and it is connected to a voltage source. Another wire is connected to a voltage source. Another wire is connected to a voltage source. I have so many sources. First source is applying voltage A0 independent of the time. Another source is applying A1 into X. When X is 0, then there is no voltage across it through that source. When time is growing X, then it is growing the voltage as per the time. Second is A1, A2 into x to the power x square. The way time is growing, it is growing the voltage as x square. Like that, like that, like that, infinite. If I add all, it will become sin x. Hey, what are you kidding, man? All are positive, then how it will come negative? Okay, probably some of the coefficient would be negative then. I don't know. It should be. Someone can check. Okay, means if I have an antenna, hope these examples are not there in any of the book. I am not copied from any book. Okay, if this is the antenna and this is positive and negative, and then I am receiving a signal through electromagnetic radiation wireless, and then whatever I am seeing in the voltmeter it has a frequency, and voltmeter is keep on changing its value. Same I can replicate if I connect these two sides with many batteries. First battery is A0 supplying voltage of the A0 independent of the time. Second is A1 into X. As X is growing, time is growing, its voltage is also growing. Third is A2 into X square. Fourth is A3 into X to the power 3. This is amazing research from Sir Taylor or Mr. Taylor. Amazing. Okay, this is the source of Euler's formula also. E to the power I theta equal to cos theta plus I sin theta. Because Euler was the Taylor series of cos theta and Taylor series of I into sin theta. Okay, or the Mr. Euler was the Taylor series of e to the power I theta. What is the Taylor series? E to the power x, what is the Taylor series? Instead of x, he put I theta. And then he was the Taylor series. And then he saw this Taylor series in mixture of cos theta plus I sin theta. And then he said e to the power I theta equal to cos theta plus I sin theta. This is the amazing thing. Taylor series is the base of innumerous inventions. Okay, because it makes like anyone can generate any kind of electronic signal. You can fake anything. Okay, or it can be used in high class testing also. That is Taylor series. Okay, Taylor and Maclaurin. Please watch our previous video, differentiate between Taylor and Maclaurin series. Okay, now we have also proved that how Taylor series comes into the picture. Please watch our previous 2 or 3 videos. That how Taylor series comes into the picture. That any sin x or any fx equal to a0 into x minus a to the power 0 plus a1 into x minus a to the power 1 plus a2 into x minus a to the power 2 into a3 into x minus a to the power 3 plus like that. Okay, okay. Then there is one Mr. Maclaurin. He is saying make a as 0. make a as 0. In that sense, we will have again fx equal to a0 plus x plus a1x plus a2x square. No need to have x at a. X minus a means if I have a sinusoidal wave, if I have a sinusoidal wave, a sinusoidal wave starts from the origin. If this is the origin, if this is the origin, then sinusoidal wave starts from the origin. X minus a means it will shift by a. Now it starts from x equal to a. This is x minus a. Mr. Taylor is saying because without offset you cannot complete any algebra. Not required that algebraic equation will start from the origin only. There is no chance like that. Okay, I have a sinusoidal wave, and when I started measuring it at time equal to t equal to 0, I saw some value. It was not 0. Like I saw this is antenna. I connected the voltmeter across the antenna, and then I started my potential meter. I started my voltmeter. Okay, at t equal to 0, I am seeing some value. It is not 0. And after some time I am seeing 0. Then someone would say your sinusoidal wave does not start from 0. It has some offset. If it has some offset, then what is the generic equation of the sinusoidal wave? It is not what is generic, then it will be shifted value by a at time a. When I'm talking about time as x, and when time reach a, then sign is 0. Then the potential meter is showing 0, and then it starts growing. Means I saw the shift of a. This is what Mr. Taylor is saying. Every polynomial not require that it will start from 0 only. It can start from any point a. That's why he said fx equal to a0, a and subscript 0, x minus a to the power 0 plus a1, x minus a to the power 1 plus a2, x minus a to the power 2. Maclaurin is saying for simplicity take a as 0. There is no problem in that. Only shifting is the concern. No problem in that. Then fx equal to a0 plus a1x plus a minus a is gone. a2x x square plus a3x to the power 3. Okay, now we are saying that the proof what Mr. Taylor has shown that how to prove the Taylor series, then what he did, if it is fx and this is a series he has to bring, then he said that you take fx as a what Mr. Taylor did. If I say I have a fx equal to Taylor series, now fx represent fx as the very ideal fx as an ideal polynomial equation. Consider like that. Then fx will become a0 plus a1x plus a2x squared plus a3. Then both are same, left hand side and right hand side. Okay. Now Taylor is saying fx equal to a0 x to the power 0 x to the power 0 plus a1. I'm sorry. Fx equal to a0 x minus a power 0 plus a1 bracket x minus a to the power 1 plus a2 in bracket x minus a to the power 2. Okay, this equal to fx. Now this you take left side and make equal to take right side. Take right side because after n this is Taylor series, that is true. But what is value of a0, a1, a2, a3? Now take this as left side. This is fx. Consider this is fx. Then then you do the differentiation of this. Then you don't do differentiate it. Consider x equal to a. At x equal to a, what is the value? Then all will become 0. X minus a terms will become 0. Only a0 will be there. Then this is equal to a0 when x equal to 0. What is this? When I do single differentiation, then a0 will go away, only a1 will remain, and then x equal to 0, other will go away. A1 equal to hope, I'll rephrase it. Consider what we are saying. Taylor series is fx equal to a0 x minus a to the power 0 plus a1 x minus a to the power 1 plus a2 x minus a to the power 2 plus a3 x minus a to the power 3. This is equal to fx. This is what Mr. Taylor is saying. Okay, if he is saying right, then I should be able to find value of a0, a1, a2, a3. This is what his fundamental is. If he is right, fx equal to a0, a1, a2, a3, a4, a5 with the polynomial, then someone should be able to find value of a1, a2, a3. Then this is right. If I am saying this is equal to this, then I should be able to find the value of a0, a1. Then he said difference. Then you tell me what is value of fx when x equal to a. If fx equal to this, then all will become 0 and will be a0. Then I, instead of a0, I strike it down and I write there fx at x equal to a. Now go ahead again. Now differentiate fx one time. In that fashion, a0 part will go away, only a1 part will remain, and other is in x minus a. What is differentiation of fx at x equal to a? Then it will be a1. Now now we will complete it. a0 into x minus a to the power 0 plus dfxy by dx at x equal to a into x minus a. a1 becomes dfxy by dx at x equal to a. Similarly, a2 will become d2fxy by dx square by factorial of 2 at x equal to a into x minus a whole square. That is a2 equal to dfxy by dx square at x equal to a by factorial of 2. a3 will become d3fx by dx cube into 1 by factorial of 3. 1 by factorial of 3, that is a3 into x minus a to the power 3. Mr. Taylor, with this fundamental differentiating fx first 0th time, first time, second time, third time, fourth time, and setting x equal to a, he was able to find the unique value of a0, a1, a2, a3 in his polynomial equation. This exactly proves that fx can be represented through polynomial equation because we are able to find all the coefficients successfully. This is what Mr. Taylor is saying. What we are saying is we can bring the polynomial representation of any fx, not going the way Mr. Taylor has gone through. Because after all, Taylor has an approximation at the end. Because he said that fx equal to a0 into x minus a to the power 0 plus a1 x minus a to the power 1 plus a2 x minus a to the power 2 plus a3 x minus a to the power 3. Later, with the differentiation, he found the value of a1, a2, a3. But whatever it is, first he made an assumption that it is like this. We are not making any assumption that it is like this. Then I have to bring I have to bring the polynomial representation of any function fx. What is polynomial representation of any function fxy? What is polynomial representation of any function fxyz in 3 dimensions? What is polynomial representation of any function fxyz alpha beta up to n term? Okay, can we find through other way without starting with any approximation at all? That is the concept we are saying. Consider I have a function like this. Consider I have a function like this. What is this function? Okay, when x equal to 0, then this is infinite. This height is infinite. See, infinite. It is asymptotic. This is called asymptotic. It is going infinite. When x equal to 1, then height is 1. It is touching 1. When x equal to 2, height is 1 by 2. It is going down. Our equation is started with infinity. When x equal to 0, height is infinity. When x equal to half, then height is 2. When x equal to 1, height is 1. When x equal to 2, height is half. When x equal to 3, height is 1 by 3. I have a function as 1 by x. Can I represent 1 by x through polynomial equation? That is the question now. Fx equal to 1 by x. I have taken as an example. What is the polynomial representation of this function? Okay, can I say, consider that I want to calculate, I want to calculate the area of this curve. Area of this will be flat. Okay, cannot go up after that. It will be down only. Okay, consider that what is the area of this curve? Area of this curve between any 2 points. Between any 2 points. Consider area of this curve between 0 and x. Area of this curve at 0 and x. Okay, looks like your 0 will be infinite. Take any fx. 1 by x I am saying. Take any. Instead of hitting it infinity here, consider it is hitting x-axis at some point. It is hitting x-axis at some point. Someone can modify 1 by x so that it will hit x-axis at the beginning, at some point, and then it will go down 1. What is the area underneath it? between x equal to 0 and x equal to x. Means area between here. What is the area here? Okay, it's a very simple. You want to calculate the area, right? Yeah, I want to calculate the area. This is x axis, this is 0. Then this is x, and at 0, what is your fx? Yeah, I'll tell you what is my fx. At 0, my fx is f bracket 0. What is the height you have when x equal to 0? Yeah, what is your equation? Equation is f in bracket x, fx. Fx is the equation. What is the value when x equal to 0? That is f and bracket 0. Then the area underneath is f0 into x. Oh, what are you kidding, man? This is the area of a rectangle. What you are saying, that is area of a rectangle. See, this is x, and you are saying height at 0. The height at 0 is f and in bracket 0. Yeah, true. And then multiplied by x. That is the area, but that is the full area. This much area. Oh, I'm sorry. I made a mistake. Then you have to decrease this. You have to decrease this area because you computed full area by f0, that is the height, multiplied by the x, that is the full area. You have to decrement this area up to here. If I take from a top a flat line, whatever coming this area, you have to decrement this area. Then you will get it. What do you mean? That is f0 into x minus this area. Minus this area. Okay, what is this area? Okay, this area, if I see, then this is x and this is something. This is x and this is something. If I take a tangent line here, then this will form a triangle. If I take a tangent line or a line that is connected, if I take a tangent line where, take tangent line here at x equal to 0, then this is the tangent line. If I take the tangent line at x0, then it will come like this. Then when x equal to 0, x equal to x, then I'll make a straight line like this, and this. Okay, this form a triangle. Can someone see? This form a triangle. Okay, subtract that. So first one f0 into x, subtract with this and take a tangent here. What is tangent? Tangent is dfx by dx at x equal to 0. That is the tangent. If this is the tangent dfx by dx, then height will be dfx by dx into x. Okay, because that is the slope, then height will be dfx by dx into whatever the x is. If I multiply, that will be the height. I am deliberately taking everything at 0 so that I did not add any offset or something like that. What if I take tangent at this point? Tangent, then it will, this is x. The tangent will hit this line x. Okay, then this is the height and this is the width x. What is the height? Dfxy by dx at x equal to 0 multiplied by x, that is the height. What is area of this triangle? Then it is 1 by 2 height into the width. 1 by 2 dfxy by dx at x equal to 0 into x, that is the height. Okay, I'm sorry, 1 by 2 into height into width, that is the area of triangle. 1 by 2 height is dfxy by dx at x equal to 0 into x. So it will be f0 into x, that is the area of the rectangle, minus 1 by 2 dfxy by dx at x equal to 0 into x, x square. Okay, this is what you want. Boss, again you made the mistake. See, you calculated the tangent at this point. Yeah, then you subtract. First you calculated this rectangle. Okay, then idea was to subtract this portion to have this area. I want this area. First you calculated the rectangle f0 into x. Then you subtracted this part. You subtracted more. Knowingly, unknowingly, you have to subtract. I said to subtract this portion only, but you subtracted more. Oh, sorry. Looks like I have to add now. Okay, what portion I need to add? Rather than subtracting only first portion, you subtracted a bigger portion. Then whatever the extra thing that you subtracted, I believe this portion, whatever, if I do like this, then this portion you have to add again. Okay, how I can add this portion? Now this is not a triangle. Now first was rectangle. Then we went through, because I thought that this is a straight line, and if I make like this, then this is a triangle. But unfortunately, if to calculate the triangle, unfortunately, I took the tangent, considering tangent will be along the line, but it is not along the line. It is like this. This portion I subtracted more. Now this portion I have to add. To add this portion, then I will go along this line again. Okay, I will go along this line again. Now I have to do triple differentiation, double differentiation. Means this curve has high complexity. It looks like a simple curve. I'm not talking about 1 by x, fx equal to 1 by x. This curve is a very high complexity. Okay, this is not a straight line even. Okay, then I'm thinking how to get underneath area that I have to add. Then I have to integrate this up to here or something like that. Okay, then I'll consider this line as a x square. If people are watching very carefully, then what I'm trying to do? First, I thought this down line as a flat line. If people are watching it very carefully, I'm trying to area. If this is fx, then I'm trying to calculate area underneath it. And by mistake, I took this line as a flat line. And then I said f0 into x is the area. Then I saw, oh, it is not a flat line. It is a slant line. Okay. Then whatever area I calculated, I subtract this slant line, that is a triangle, this triangle. Then I subtracted this triangle. Okay, to get the slant line, I differentiated at this point. Then I am watching it. This is not a slant line. This is little bit curve, and I by mistake I subtracted more than required. This portion also. If this is a curve, then I thought, oh, this is not a slant line. I know it is not, but this looks like this is x square. First I saw it is a constant, then I saw it is a x. Slant line means y equal to x in that form. Then I'm saying it is not a slant line, it is like some x square, next degree. I'm going to next degree. Okay, what is the area underneath where it is x square? Then whatever I'll get, then I'll say now you add it. First is f0 into x minus 1 by 2 dfx by dx at x equal to 0 into x squared plus whatever you get through the x squared fundamental, because you thought it is next degree. Still something you are missing, either in negative or positive side. Okay, sorry, looks like it is even more degree, x to the power 3, even more degree, x to the power 4, even more degree. You go and make finer, so that at the end you will come to the area what you want. Makes sense? If I have this is x-axis and this is y-axis, if I have any curve like this, I want to calculate the area underneath. First, I will consider this curve as a flat line, and then I'll calculate the area. Then I'll say, oh, I'm sorry. Actually, this curve is a straight line. Then I'll subtract the triangle, what we have calculated, the area of rectangle minus this triangle. Consider this will fulfill our need. Then I saw, while calculating the triangle, I had thought this dy by dx will be constant. First I thought f0 will be constant. Then I thought dfx by dx at x0 will be constant. That is also not constant. Then I took as x square. Then I thought double differentiation will be constant. Then again it is not constant. Then I took triple differentiation. Means first I took rectangle, then subtracted the triangle. Then I am adding this portion because I thought I subtracted more. Then I keep on I'm doing the mistake. Mistakes is proceeding. But the area in coming under question is thin. This is called approximately. We are trying to calculate the area. Approximately, we are trying to calculate the area by successive calculating the area. This is our proof. Okay, in that fashion, how it will be? So it is f0 into x. Okay, leave the minus sign plus 1 by 2 dfx by dx into x 1 by 2. Okay, what is that dfx by dx? If I have a straight line, dfx by dx will be a constant. If I have a slant line, then dfx by dx will be a constant. In that fashion, if this is a line where equation is y equal to x y equal to mx, then dy by dx equal to m. That is a constant. If this is a straight line, if this is a slant line with x-axis, then dy by dx will be flat line because it is a constant. Okay, means if I'm trying to calculate that, if I'm trying to calculate the triangular area, the triangular area will become rectangle if I differentiate one time. If I differentiate by dfx by dx, dfx by dx is rectangle, is a flat line, same as calculating the rectangle. So if I calculating the rectangle, one side is x, and what is the height? Height is 1 by 2 dfx by dx at x equal to 0 into x. That full is the called vertical part, which is a constant. Means for a triangle 1 by 2 dfx by dx at x equal to 0 into x is a constant. Into x, that is area of the rectangle. Means first is rectangular area plus triangular area plus third is the area that is formed by a line x square, because now I am going to another degree because we are constricting the area final. What is the area with the x square if I talk about it? Okay, if I take first differentiation of x square, that is dfx by dx, first differentiation, then x square will come in term of x1. Okay, if it comes under x, then I know the area. What is area? The area is 1 by 2 dfx by dx, dfx by dx into x. I know. Okay, but problem here is dfx by dx, where fx is first derivative. One derivative already I have made. Okay, means I am trying to break x square to come to a rectangle. So first it will pass through triangle, then it will come to rectangle. If I am trying to bring x as a rectangle, then first differentiation will bring it to rectangle. If I am trying to bring x square as a rectangle, then first it will come to triangle, then it will come to rectangle. If it is coming to triangle, then afterwards it is 1 by 2 d2fx by dx square into into x, whatever dfx by dx I am passing to it. Okay, means layer by layer we are going up, and what is changed I am seeing? The first layer is f0 into x, that is the rectangular. Next layer is 1 by 2 dfx by dx at x equal to 0 into x. That whole term is replacing f0 and into x. If I go up, then up will give the responsibility to lower layer and to lower layer. It will add something out there. So if it is going from the second layer to the first layer and zeroth layer, second layer if I see, then what it is passing to the second layer, top layer, what it is passing to first layer, it will pass 1 by 3 dfx by dx into x. Okay, and then first layer will apply it as 1 by 2 into whatever is come d2fx by dx square into x. More or less it will become 1 by 3 into 1 by 2 into d2fx by dx square at x equal to 0 into x square into x. Okay, this much it will come, x to the power 3, and it will reach at the bottom. Okay, if it is reaching the bottom, then it will bottom is as it is. People should think more about it. Means more or less the area covered for the rectangle is f0 into x. The area covered for the slant line, what I am thinking, the next degree is 1 by 2 dfx by dx by dx at x equal to 0 into x. The next layer, if I talk, then it is 1 by 3, and then d2fx by dx square into x square into x. Okay, someone can think more on it. How to then if I go up, means go up, then it will be 1 by 4 dfx by dx into x. Like that. Someone can now ascend it the way I am thinking. Okay. The bottom is f0 into x, top f0 into x. Whatever is coming from the top, you multiply by x. From top, it is coming as 1 by 2 f0. Here, f0 into x. What is f0 if it is a triangle? Then f0 is 1 by 2 dfxy by dx at x equal to 0. f0 means flat line. If it is a rectangle, then flat line, that is the height, that is f0. Height by width is the area. What is the height? When I am talking about rectangle, that is the zeroth level, then height is f0, that is fixed, multiplied by x, that is the area. If I come to first level, where the top is not a straight line, it is a slant line. If I do first differentiation of the slant line, then it will become a flat line. It becomes a flat line, then give the flat line to the bottom layer and it will multiply by x and it will settle it as the area. Okay, the first layer it is giving flat line as 1 by 2 dfxy by dx at x equal to 0 into x. That is the flat line. Flat line height it is passing to the bottom layer. Bottom layer is simply multiplying it with x. Okay, it looks like that. We have proof for it. Okay, what about top line? Top, that is the first zeroth layer, first layer, second layer. Second layer will pass a slant line to the first layer. First layer will convert slant line to the flat line and pass it to the lower layer. What is the first, second, zeroth layer, first layer, second? Second layer has a formula in x square. If it is x square, then it will make a differentiation, and then it will make a slant line. Differentiation of x square is in x only, that is a slant line, and it will pass to the first layer. First layer will whatever comes from the top layer as a slant line, it will multiply it with 1 by 2. It will take a differentiation again and it will multiply with the x, claiming it is a flat line. So top layer is now it will pass 1 by 3 dfx by dx, okay, into x. It will come down here. Here it will multiply it with 1 by 2 into, again it will differentiate once, d2f by dx square into x. X was already there. Now it will become x square. Okay, now this is a flat line. What is flat line? What is a slant line? If I talk about zeroth layer, first layer, second layer is passing a slant line equation to the first layer, and that slant line equation is 1 by 3 dfx by dx into x. That is the equation of slant line it is passing to the first layer. First layer is understanding if it has the equation of slant line, how it can convert into a flat line by multiplying it by 1 by 2, differentiating it, and then multiplying it by x. Okay, then it will become 1 by 3 into 1 by 2, and then differentiating it, d2fx by dx square at x equal to 0. X is already coming and one x will be attached, x square, and that will be passed to the zeroth layer as a flat line. It will multiply x directly there, saying this is what your area is. Means area when it is a rectangle, then it is f0 into x. Area when it is a triangle, then it is 1 by 2 dfx by dx at x equal to 0 into x into x. If I go top, then area contributed by that line x square is 1 by 3 into 2. 1 by 3 into 1 by 2 d2fx by dx square into x into x into x, x to the power 3. If I add all, then slowly I'll come to the perfect area underneath this. Perfect area underneath this means settling down the rectangle, settling down the rectangle. Then sorry, I have to subtract the triangle. I'm sorry, I have to add this. I'm sorry, I have to subtract this. If I keep doing that, finally I'll come to exactly fine area underneath it, where I'll keep on doing it till n tends to infinity. Means what is the actual area here? That is fx dx. If this is fx and this is y-axis, this is x-axis, what is area underneath it? Fx dx. Fx dx integration equal to whatever area I have calculated. Differentiate both sides. You will get the fx. Differentiation of fx dx is fx. Fx equal to, not differentiated. First is f0x, it will become f0 plus 1 by 2 dfx by dx into x square. Dfx by dx at x equal to 0 is a constant. Actually, it is a constant. So x square will get differentiated. 2x, 2 gone. It is dfx by dx x plus. Then third term, 1 by factorial of 3 d2fx by dx square at x equal to 0 into x to the power 3. Differentiation will be 3x square. 3 gone. It will come as factorial of 2 d2fx by dx square into 1 by 2 factorial and then x square plus. Now next term will be 1 by factorial of 4 d3fx by dx cube into x to the power 4. If someone differentiate, it will become 4 into x to the power 3. It will remain as 1 by 3 factorial d3fx by dx square at x equal to 0 x to the power 3. Like that it will go on. This is actual Taylor series, not the way Taylor had proved his Taylor series by approximation. First, he took as a polynomial, not required. We can do by dividing our area into n different parts and then solve part by part and then add it. You will get the Taylor series. We'll talk about the multivariable Taylor series also. I believe it is understandable that how we will proceed. Right now, we are proceeding with the calculation of area and dividing the area into n different parts where n tends to infinity. Okay, can we achieve this similarly with calculation of volume and dividing volume into n different parts where n tends to infinity? And we will try to come up with the multivariable Taylor series. Please do not mind supporting us. I'm really sweating. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone.